Well, say hello to our sister planet, ladies and gentlemen. Although it's a few light years away, which if you move at light speed isn't that bad. GC 667cc, obviously, could be the closest planet outside of our own solar system with temperatures and overall atmospheric conditions, I think of an orchestra of variables, that could support a formation of water and life not dissimilar to that we know here. According to astronomers, this GC planet that rolls right off your tongue, I don't remember it right now, lives in the so-called Goldilocks zone, where it is neither too hot nor too cold. Think oxygen densities, nitrogen densities, all these things. But the difference is that good old GC 667cc, there it is at least 4.5 times bigger than Earth, making it what scientists call a super-Earth. Super-Earths are what our next guest has been on the hunt for his entire career, and he's a happy scientist today. Dimitar Sasselov, director of Harvard's Origins of Life and the initiative, one of the leaders of NASA's Kepler mission to discover Earth-like planets orbiting stars, author of the book The Life of Super-Earths. There it is. Check it out. The hunt for alien worlds and artificial cells, how it will revolutionize life on the planet Earth. Everybody knows and is learning that life is an experiment, and that any experiment requires a goal. In your case, you wanted to identify these planets, and then a methodology to achieve that goal. Your methodology was to observe the current environment and then see whether you could find indications of similarity throughout the entire universe. How's it going?
It's going great. These planets, called super-Earths, as the name implies, are bigger than our own Earth. They're a rich family. Our Earth is part of that family. Some of them may resemble very much the Earth, others are different. It's a family that we are already discovering.
What's the breakthrough for the experiment that has allowed you to observe whatever the variables are you're observing in our world here, that you can then search the universe trying to match them?
There are a couple of them. The first breakthrough was figuring out how to find them. And in that sense, the NASA Kepler mission revolutionized the field. In the last 2 years and for the few years ahead, it's going to really discover all those planets in a way in which we can then study them and understand how often they happen.
So the astronomy said now you could basically observe the experimental field that is the universe to see whether they're there.
Yes, they're in our own galaxy. They're light years away. But we see them, and we can tell how often they occur around other stars.
And then what are you using to understand where we live to know whether what you're seeing out on the Kepler system is similar to where we are?
Now, that's the big question. We want to know which of those planets are similar to Earth and how often do you have the same environmental conditions. So you have to then use other telescopes and maybe discover more of them nearby to tell what's going on. And in that sense, we have super-Earths, which are easier to study. So it's a practical aspect. We could find planets like the Earth, but super-Earths are slightly bigger, easier to study. We can apply our knowledge of chemistry and biology to actually get to know what's going on.
And so, and I want to go to the title of your book. You say how the hunt for alien worlds, another planet obviously, and artificial cells will revolutionize life on our planet, which is really your punchline, right? Is that we're not all going to live on super-Earth. It's that we're going to learn things about super-Earth that will revolutionize the way we live here.
Absolutely.
Revolutionize my life in fantasy land.
Absolutely. That's the point of this book. Is the punchline is that what we are learning from the environments on all those other planets is bringing to us some knowledge that we can apply in the lab. And this new field of synthetic biology in which we can understand some of the basic chemistry of what we call life, some of its basic functions, which then would allow us to have the synthetic tools to create new materials, to actually do things which we cannot do today.
So you're suggesting that you believe that you can reveal through experimentation with astronomy and earthbound biology meets Kepler-bound astronomy. You believe that you can marry that experimentation to reveal methods to actually not just do regenerative work, but to do generative work, actually originate new materials. Is that
precisely
right?
Generative meaning synthesis, synthetic tools. The unlikely
what are you going to
marriage.
make? What give me an example?
An example would be historically, organic chemistry is producing new materials, plastics. We use them every day today. That's pure chemistry. But now imagine that you can produce a biochemical material which has some heritage, some self-knowledge of what it is. Software and hardware are married organically into the same material. That material is going to be self-sustaining, adaptive, organic, much more so than a plastic which is inert.
But are you imagining this as a biological, this is a diagnostic and tissue repair, human biology? This is the way we live. My house is built of this material and then rapidly dissolves to nothing when I'm done with my house? I mean, what are we talking?
It is more of the latter, although I hope that your house doesn't dissolve.
Well, maybe when I'm done, why not?
It is at the level which is simpler than what our bodies are. So we're talking more about materials rather than regenerative medicine, which is a very different.
So you're talking about basically mass, this desk.
We're talking about chemistry,
and
a more powerful chemistry.
Understood.
And this is what is helping us then look for life on other planets, and vice versa. Other planets' chemical environments are teaching us how to do this in the lab. And
where are you on the experiment right now, and relative to our fantasies while we talk about the future of the experiment?
The experiment on the astronomy side is going great. We're discovering more and more of those planets. In the next few years, we'll be able to study their chemistry. The experiment on the biology side is just starting, but it's very promising. And hopefully in the next few years, they'll come together.
Well, I hope so. Whatever it is, obviously you've already learned a tremendous amount and shared it with us and shared it with more folks who read the book, The Life of Super Earths. Dimitar Sasselov. It's a real delight to make the acquaintance. Congratulations on the success of the experiment to this point.
Thank you. Pleasure to be here.
Yeah, thanks for coming out.